In the vast and majestic constellation of Orion, one of the most recognizable star patterns in the night sky, lies a celestial giant that has captivated astronomers for centuries. This star is Betelgeuse, a red supergiant star, known not only for its striking reddish hue but also for its enormous size and mysterious behavior. Much larger and far more massive than our own Sun, Betelgeuse is a star nearing the end of its life, and in recent years, it has displayed some unusual and puzzling changes that have sparked global scientific curiosity and excitement. Betelgeuse, sometimes affectionately called the shoulder of Orion, due to its position in the constellation, is a true cosmic behemoth. Its diameter is roughly 8,000 times greater than that of the Sun. To put this into perspective, if Betelgeuse were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, and Mars in the process. It's difficult for us to truly imagine something of such colossal size existing in our galactic neighborhood, only about 650 light-years away. What makes Betelgeuse particularly fascinating is not just its size but its behavior. Over the past few years, astronomers have observed significant fluctuations in its brightness, including sudden dimming events that have never been seen on such a scale before. In late 2019 and early 2020, Betelgeuse mysteriously dimmed by almost 70%, an unprecedented event for such a bright star. This dramatic dip baffled scientists and stirred much debate about what might be happening deep within this ancient star. At first, the dimming was thought to be caused by a large cloud of dust ejected from the star's surface, temporarily blocking some of its light from reaching Earth. Later studies confirmed that a vast amount of stellar material had indeed been thrown into space, creating a haze that partially obscured the star. But this was only part of the story. The changes in brightness hinted at deeper, more complex processes occurring within the star's core, processes that could be precursors to a much more significant event, a supernova. A supernova is one of the most spectacular and energetic phenomena in the universe. It marks the explosive death of a star, releasing more energy in a few seconds than the Sun will produce over its entire lifetime. For a star like Betelgeuse, which has burned through most of its hydrogen fuel, this explosive finale is not just possible, it is inevitable. The exact timing, however, remains one of astronomy's greatest mysteries. To understand why Betelgeuse behaves the way it does, we need to explore the life cycle of massive stars. Stars like our Sun generate energy through nuclear fusion, where hydrogen atoms combine to form helium in their cores, releasing vast amounts of light and heat. This process maintains the star's outward pressure, balancing the inward pull of gravity. But massive stars burn their fuel much faster and evolve more rapidly. Betelgeuse is currently in the late stages of its life, having exhausted the hydrogen fuel in its core. Now, it has moved on to fusing heavier elements. Helium atoms fuse to form carbon, carbon fuses to form oxygen, and this chain continues until iron accumulates in the core. Iron is a critical element in the star's life cycle because it does not release energy when it fuses, unlike lighter elements. Once iron builds up, the star loses its ability to support itself against gravity. This loss of pressure causes the core to collapse catastrophically, resulting in a massive explosion, the supernova. When this happens, the outer layers of the star are blown into space at incredible speeds, producing brilliant light that can outshine entire galaxies for weeks or months. Betelgeuse's supernova will be an event of cosmic proportions visible from Earth. Scientists estimate that when it explodes, the brightness of Betelgeuse's supernova could rival the Moon, lighting up our sky even during the day. Although 650 light-years may sound close in cosmic terms, this distance is safe enough that the explosion will pose no harm to life on Earth. The fascination with Betelgeuse extends far beyond modern astronomy. Historical records show that ancient civilizations noticed this star's unique characteristics. Chinese astronomers from the 2nd century BC described a bright red star in Orion's shoulder. Centuries later, Greco-Roman astronomers, including Ptolemy, recorded its reddish-orange color, a feature that has persisted through millennia and across cultures. Medieval astronomers in the Middle East also observed and documented Betelgeuse's fiery glow, often associating its color and brightness with mythological stories and celestial omens. These long-standing observations provide a rich backdrop to modern science's efforts to decode the star's behavior. Returning to the present, recent observations have revealed more peculiarities. After the dramatic dimming in 2019-2020, Betelgeuse's brightness increased again by almost 50%. A surprising reversal given that aging stars generally tend to grow dimmer over time. This brightening could be the result of dynamic processes within the star's outer layers or an indication of pulsations caused by internal instability. Astronomers compare Betelgeuse's behavior to that of Mira variables, stars known for their periodic expansion and contraction that cause cyclical changes in brightness. Mira, often called the wonder star, fluctuates noticeably over approximately 332 days, and similar variability is seen in about 30 other stars easily visible to the naked eye. What makes Betelgeuse unique, however, is the sheer scale of its fluctuations combined with the star's imminent fate. The star's core is a furnace of nuclear reactions, continuously changing and releasing bursts of energy and matter. Some of these eruptions propel vast clouds of dust and gas into space, creating nebulae that envelope the star and influence how much light we observe. These dust clouds and mass ejections are not just visual curiosities. They help astronomers understand the star's internal dynamics and provide clues about the processes leading up to the star's final moments. Adding another layer to the mystery, some researchers speculate that Betelgeuse might have already undergone a supernova event, one whose light has yet to reach Earth. Because the star is 650 light-years away, any explosion we see happened centuries ago. While this is unlikely given current observations, it remains a fascinating hypothesis fueling debate. Kepler's supernova, observed in 1604, was another remarkable stellar explosion in our galaxy, reminding us that massive stars end their lives in these powerful outbursts. Betelgeuse could be the next in line. Scientific models suggest that Betelgeuse is currently burning carbon in its core, indicating it is in a late evolutionary stage. This supports the idea that it may explode in the near cosmic future, perhaps in a few thousand years, or maybe even sooner. Unlike the steady, slow evolution of smaller stars, the changes in Betelgeuse are rapid and dramatic, providing a unique window into stellar death throes. Betelgeuse's story is not just one of destruction but also of creation. The material expelled during its supernova will seed the surrounding space with heavy elements essential for forming new stars, planets, and even life itself. This cosmic recycling is how the universe enriches itself, making Betelgeuse's final act part of a larger, ongoing cycle. As we watch this giant star with modern telescopes, both on Earth and in space, we gain valuable insight into the life and death of massive stars. Instruments like the Hubble Space Telescope and the Very Large Telescope Array provide detailed images and spectra, allowing scientists to map changes in Betelgeuse's atmosphere and dust clouds. The James Webb Space Telescope, with its powerful infrared vision, will further unravel mysteries hidden behind the dust and gas that obscure Betelgeuse's surface. For those curious about where to find Betelgeuse in the night sky, it is located in the upper left corner of Orion's iconic hourglass-shaped figure. It shines as a bright reddish-orange star, easily visible to the naked eye in winter months in the northern hemisphere. The star's color and brightness make it an excellent target for amateur astronomers using small telescopes or even binoculars. Observing Betelgeuse over time allows enthusiasts to witness firsthand some of the variability discussed by scientists. So, what does the future hold for Betelgeuse and for us watching from Earth? While no one can predict the exact day when this cosmic titan will explode, we can be certain that when it does, it will be one of the most awe-inspiring events ever seen in human history. In the meantime, Betelgeuse continues to pulsate, dim, brighten, and shed matter, a vibrant reminder of the dynamic and ever-changing universe we inhabit. Now, the question remains: has Betelgeuse already exploded, and we just haven't seen it yet? Or is it quietly preparing for its grand finale? We invite you to share your thoughts and theories in the comments below. If you found this exploration of Betelgeuse fascinating, please like this video and subscribe to the channel so you won't miss future cosmic discoveries. Thank you so much for joining us on this journey to the shoulder of Orion's warrior. Until next time, keep looking up. The universe always has new wonders waiting to be discovered.